Okay. Well, I have thoughts on this matter too, so I'm glad it's my presentation. Okay. Actually, only half kidding. But I do have this presentation. We'll touch on this in a sec. But anyway, we will get there. So hi, I'm Justin Merz. I'm from the UC Davis Library. I'm the research support engineer there, kind of play developer research support engineer role. And I will be giving a presentation on our kind of role at your own implementation. We call it FIN. My colleague Quinn Hart mentioned it yesterday. So it's a general application microservice framework built around Fedora. And then we currently have two applications that it's powering, our DAMs, and then Aggie Experts, which is a research information management system. And so this talk is kind of like trying to give an overview of what we built. So I could really split this a lot of different ways. I'm going to kind of try to keep this view of Fin of the data management side versus the application layer. So I'm going to start with kind of our source. It's the source of truth, if you will, in data management speak. We normally like highly replicatable backups, often user manageable. So think like GitHub for metadata, cloud storage for binaries. And then this is ingested into the LDP using the standard fcrepo HTTP APIs. And then additionally, you can trigger external workflows, and I'll get into this in a second. But that can be something where either you're running harvest or you're creating additional products based on your imagery. And that's why I kind of draw this cycle here. It just depends on which application and what you're implementing. Then we use, as we've talked about, OCFL for archive and preservation in an appropriate format. And part of this data management layer, I'll kind of tie into these conversations, is trying to get everything ready so when we write to that OCFL, it's what we want to preserve. And then we use the standard messaging and wiring formats that fcrepo provides. And then that kind of talks over to our application layer. And there you can define data models that perform your ETL to ingest into your application-specific database. And then those data models can also provide additional API layers to power your application. They also finally can provide data validation. And finally, then you bring your own your user interface. So by default, Fin is a headless service. So kind of overview continued. I've mentioned it's an extendable microservice framework built with Fedora at its core. It is so because it's all microservices, it can run in Docker, Docker Compose, Kubernetes, in a hosted container environment. All the major clouds have them. They all name them different things. And then what we do is it comes bundled with a bunch of opinionated services. And what I mean by that is a lot of this we've tried to be extendable. So you can use any database authentication system, workflow system. But we have ours that obviously we program to. So we use Keycloak for authentication, which we host in the library, which ties into CAS, which is our central authentication system for UC Davis logins. It also means we speak a lot of DWIT tokens with our authentication. We have elasticsearch is our main backend we use for our applications. And then like Google Cloud workflows, we do a lot of stuff in Google Cloud. So that's our workflow management system. And then as we had mentioned, it's been supporting the DAMs and our Aggie Experts. So some of the core components for the Fedora side, we have initialization and configuration services. We actually have the service extension layer where you can, we extend fcrepo endpoints to /service/IIIF. I'll show you some examples of this. And then we have quad caching for performance speed up, where applications can define quads that they want cached inside Postgres. And then this can help speed up internal components and ETL pipelines. Messaging, we actually have extended Fedora's messaging support to support AMQP protocol. So this allows us integration with RabbitMQ, which we use and love. And then we have a bunch of integration tests. So every 5 minutes, the thing spawns off test container creation and make sure all hears back from all the microservices, and they can make sure everything's up and running and performant. And then we have even custom messages. So obviously this application database, like everything, needs a reindex service. So those messages can be passed on that bus as well. The data models, they're, like I said, they perform ETL services, which basically move data from the LDP to your application database, including some validation. They bind to containers by the LDP path or the container type, and then they can define their own APIs. And administration out of the box, you get a command line interface to do a lot of the work. And then we have an admin client as well that comes pretty fully featured, and that's using PG REST. And the backend, if you've never looked at that service, I highly recommend it if you are a Postgres shop. Let's see. So core components continued. So we have third-party workflow management integration. And what that really means is that Fin will push data from your LDP to like a cloud bucket. It'll start a workflow with pointers to where it pushed that data to. It'll monitor that workflow, and then it'll alert when it's completed or failed. I said we use Google Cloud Workflows, so our stuff's all wired up, so we can use Google Cloud Workflows just out of the box, but it'd be really easy. Any workflow system with a decent API should be able to be plugged in. Authentication, OIDC authentication services, we use Keycloak out of the box. It's fully extendable. Authorization, we try to get in the Fedora box as much as possible, so we are using Web ACL, and then we just have an opinion layer over the top of that, which really just has a predefined set of roles for the ETL services to know what to speak and what they can talk to. Label service, we have created a nice label service so we can use URIs instead of text labels and having to replicate those everywhere. And then the client service is something you tack on at the end, which is, again, it's headless by default and defined by your application. So here's kind of going back to that first slide, an example of what a UC Davis application looks like. You have some Google Cloud Workflow, which ends up in storage, listens to pub sub events. We have this service called GCS Sync, which actually pulls from Google Cloud Storage and uses the right APIs to push to the LDP. Or we have FinIO, which is it's a file. We have a file system representation of the LDP, and FinIO is able to synchronize that and use standard the LDP API to actually push the data there. And then that's really nice for getting data, can be stored in GitHub and have lots of all the goodness you get out of GitHub, issue tracking, PRs, all that type of stuff. And then when things are ready, you can actually use FinIO to push it. So then we use the RabbitMQ plugin, Shovel plugin, which takes these messages from the LDP and puts them into a fan out exchange and provides us the ability to fan out to multiple queues, which is can be both ephemeral or static. Then DB sync service, which is basically the ETL step that takes it from the messages from and the data from the LDP, and then leverages your data models to perform all your CRUD operations on your database. And then finally, your client UI can leverage your data model APIs to actually be powered, in this case, like we use elasticsearch. The thing I kind of want to note here in this slide is that the rectangles, the rounded rectangles are services that we already have written in Fin. A lot of these services, obviously, you'll recognize are open source products. So really, it's just these ovals when we go to write an application in your schema design that we can come to the plate now, because like the two applications we have are very different. And the idea is we might have a couple more come down the pipe, but we can just really focus on schema design, what application, what data model needs to happen there. And then, if we want to switch up what database is best for that, we can do that. And then you bring your UI, because we find that's always pretty application specific. So data management, I'll dive into this, kind of talking about our what we were getting into, especially this last slide or this last bullet point. FinIO is, like I said, it's a human editable file system representation of the LDP. Really nice to put it. You can look on our GitHub. You'll see lots of our metadata stored in Git repos and can be tracked and versioned and all that type of stuff. And then we have different products that we actually store in Google Cloud, and we'll synchronize down to the LDP, or we'll have stuff where we'll store some application configuration and want it backed up in a bucket, and we'll push it up there, back up to cloud storage. So that synchronization service can go either way. Then for speed up, we have this thing called the Fin Cache, which allows you to predefine quads that'll get shoved into Postgres for fast access. And then we leverage that, and we've actually extended the digest header so we can store application-defined digest for metadata checks. So, and a good example of this is Google Cloud Storage provides you an MD5. And that MD5 is of the file, the metadata file that, or binary that we put into, well, metadata files are kind of better because those are the ones that don't, Fedora doesn't support really out of the box. And so we can have that hash of that file, we can store it in Fedora, and then if a resync comes in, we can check that hash and perform no update. And so what this really allows us to do is not only is a huge performance savings to just quickly ask Postgres, hey, this SHA matches, move on. But then, as we've been talking about, and I'll get into it in a sec, it allows us when we create, we use archival groups, we use transactions, and then with these SHA checks, we can make sure we only make updates when something's really updated, and it keeps that version line that everyone's talking about from ballooning on us. And even then, we have the option to blow away, and you'll see here some of our CLIs allow you to use a delete and actually just start from kind of version 0. So administration, here's a snapshot. This comes out of the box of the admin tooling. You can see you can administer a lot of the application. This is just a snapshot of like the data model support. It shows you how many items have made it into your database. Data validation errors, you can quickly jump to them, sort to them. You can navigate fcrepo per container. You can see what fin operations have run. The synchronization services, validation, workflow services, elasticsearch index management, which is really nice for upgrades. So we can actually store multiple indexes and coordinate upgrades. Google Cloud Sync, the health services I talked about, so the real-time integration testing, and then you can poke one of those tests at any point you want. It also has endpoints, so you can have real-time monitoring of whether or not these messaging services and all your microservices are up and down, and then service registration and config. So here's the CLI. You can see here for FinIO, this is an example, and you can see like a lot of our options are based on this SHA checking and like, hey, I want you to ignore the SHA checks and just push anyway. And so this CLI also wraps the full API for Fin, so we can interact for fcrepo. So we can just directly talk to fcrepo with this command line tool as well. So I just wanted to give a quick kind of little bit more technical dive of how we put all this together. So this is the gateway service. It's kind of the heart of Fin, and it's just a big proxy service. The services are configured in the LDP, so we really are trying to dog food the system as much as we can. So you add a service, and then the gateway listens to that, and it tells it how to route its paths. There are some statically defined routes in Fin. We expose fcrepo through the world, so you always got to make sure your WebAC is correct. We have an authentication endpoint for the authentication services, and then we kind of steal the Slack Fin endpoint for like Fin specific stuff, like the admin UI. We provide a proxy to the RabbitMQ UI only to admins. So that's kind of nice. And then we have this idea of global services, and those can tack on to and actually add routes to like the root and select the API service, which is how those data models provide their API. That happens at a global service. And then we have this idea of these proxy services, which extend the LDP using, like you can see here, the little service IIIF, and then you could provide IIIFs and work on those parameters. And then this is just a quick example. I think I'm running short on time, but that you can get. Here's an example that here's an LDP path, and this is the IIIF service, and this is getting the info.json from a generated TIFF in the cloud. That actually would then, instead of going to the LDP with the gateway, would proxy it to our IIIF service. And then actually we use a Google Cloud Fuse mount to mount. This allows for scalability because we can push all these huge tile TIFFs to the cloud. They only synchronize down what they want, and our IIIF service we're using expects those files on disk. Well, it doesn't know any better because it's just a GCS. So that's kind of my flow-through overview of Fin.
Awesome. Thank you so much, Justin. That was great.